Hello everyone, so here we have a grade 10 maths paper 2 exam written in June 2019, 1 hour long, 50 marks. Let's get started. Oh, and if you want to download the paper, just check the description below. A right angled triangle ABC with sides A, B, and C and an angle theta is drawn below. Write down the ratio of the following in terms of ABC. Okay, so for 1 mark, we need to get cos theta. So here we typically use SOHCAHTOA or whatever else your teacher has taught you on how to remember sin, cos, and tan. Now they've asked us for cos, so that means that cos theta is equal to adjacent, that's what the A stands for, over the hypotenuse, that's what the H stands for over there. Hypotenuse. Alright, so what we do is we go to theta. Now remember, what is the adjacent? The adjacent is the side that is, or let's first start off with the hypotenuse. The hypotenuse is the longest side of the triangle, so that's the one that's opposite the 90 degrees, so that would be C. Okay, so cos theta would definitely have a C over there, and then the adjacent of theta is the side that is next to it. Now some of you might say, yeah, but Kevin, isn't C also next to it? It is, I agree, but you can't have this one being an adjacent and the hypotenuse. It's only the hypotenuse. So then the only adjacent one, which means next to, would be B. And so there's the answer. Now let's go do this one. So sin 90 minus theta. Okay, so where is 90 minus theta? Because I see a theta over here. I see a 90, but where would 90 minus theta be? Well, let me try to show you. So you see this angle over here. Let's go, how would you calculate that? Well, we know that all the sides of a triangle must add up, all the angles in a triangle must add up to 180. So we could say theta plus 90 plus angle B must always add up to 180. And that's just because of some angles of a triangle. So if you had to go calculate this part, you would take the theta and the 90 to the other side, so that would become negative. And then if you had to solve, you would end up with 90 minus theta. So that means that this angle is called 90 minus theta. So now what they want you to do is to go and work out what is the sin of that angle. So it means you're going to be at this angle over here, and you're going to work out what is sin. Now remember that sin is opposite over hypotenuse. Let's just write that for ourselves. Sin is opposite over hypotenuse. So the sin of 90 minus theta, so now that means you must look at this angle. So what is the opposite? Well, the opposite is B, and the hypotenuse is C. And so there's the answer. So this one was B over C, and this one's B over C. Make use of the diagram below to answer the questions without the use of a calculator. Okay, so before we even get to these next questions, we need to complete the diagram. So remember, when you get a diagram like this, always make the triangle, this part, go towards the x-axis. Okay, always make it go towards the x-axis. Don't ever let it go towards the y-axis. So if you did this, that would be wrong. Okay, so you're going to go that way. Now, let's forget about that quickly, and let's pretend that this line was not here. Okay, so let me just get rid of this line. Okay, and let's say we just had this random point P. Now look at its x value, that's 3. So that means that this distance here is 3, and then its y value is negative 4. So that means that this distance is 4. So now you could just use Pythagoras to work out what that distance is. But remember that this is a negative 4. But when you do Pythagoras, you don't have to use a negative. So you can just say 3 squared plus 4 squared, and that would give you 25. Then the square root of 25 is 5. So I just did Pythagoras to find this one. This part is always positive, whether we were there, or there. It will always be a positive for this part. Okay, now that we have the triangle complete, now we can go and answer the questions. So it says, what is, so it says a quarter sin squared of theta. Now I know that that looks scary, but you can actually just write it like this. You can say a quarter sin theta, and whatever that is, squared. So all that we really need to go find now is sin theta. So we can use SOHCAHTOA, or however else you like to do it. Some learners like to use y over r, x over r, y over x for sin, cos, and tan. That's also okay, whatever you're comfortable with. But I like this method. So we're going to go look for sin of theta. So that would be, you can just take it as that little angle there. And so sin is always going to be opposite over hypotenuse. So what is the opposite? Well, that would be negative 4. And then what is the hypotenuse? The hypotenuse is always the longest side of the triangle, and that's 5. Okay, now I'm just going to take that and plug it over there. So some learners think, wait, Kev, do we plug it into the theta or do we plug it into this whole thing? We plug it into the whole thing because look here, we're saying that sin theta is minus 4 over 5. So this whole thing is minus 4 over 5. So we're just going to do that. Okay, now if you take minus 4 over 5 and you multiply it by itself, that becomes positive 16 over 25. Now, if you had to go work this out, we should end up with 16 over 100, or however else you want to do it. You can do top times top, bottom times bottom. You could cross cancel. You can do a couple of things here. But once this simplifies, it should give us a final answer of 4 over 25. Okay, this one says, show that this is equal to that. Now we're allowed to use the diagram, so let's go work out. Remember, when you see sec squared theta minus 1, you can just think of it as sec theta squared. Okay, so let's go work out that side first. So let's just say we're going to work on the left hand side so long, so that's this side. Now remember that sec, let's give you a quick little recap. Sec is 1 over cos. Cosec, or let's write it out as cosec, is 1 over sin, and then cot is 1 over tan. So we need sec. So sec is 1 over cos. So let's first go find cos. So cos theta is adjacent over hypotenuse. And so that's going to be, if you start here, the adjacent would be 3, and the hypotenuse is 5. So then sec is 1 over that. So sec theta is going to be 1 over 3 over 5. Okay? If you type this on the calculator correctly, you should get 5 over 3. If you end up with 1 over 15, you've just typed it on the calculator incorrectly. And specifically, if you got 1 over 15, then what you've done is you've written it like that. Okay? Where the bigger line is there, but you rather want it to be the bigger line there. Like that. There's a difference. Okay, so we know that sec theta is 5 over 3, so we can say 5 over 3 squared minus 1, and so that's going to give us 25 over 9 minus 1. Get a common denominator, so that'll be 25 over 9 minus 9 over 9, and that should give us 16 over 9. Okay, so now that's this side. Now we need to go quickly work out this side, so we'll call that the right hand side, so we'll just say RHS. Okay, so we just need to go work out tan, because remember tan squared theta is the same as tan theta, and then you square that. So tan is opposite over adjacent. So tan is opposite over adjacent. So if you start here, then the opposite would be negative 4. Well, let's first work it out here. So tan theta would be negative 4, and then the adjacent would be 3. So we're just going to put that into a bracket and square it. Now, what is minus 4 over 3 multiplied by minus 4 over 3? Well, that's just going to be positive 16 over 9. And so what we can see is that this side and this side is the same. And so we can just say, therefore, sec squared theta minus 1 is the same as tan squared theta. This question says, use your calculator to determine the value of the following correct to 2 decimal places. So they're literally saying use the calculator, and it's only for 1 mark. So all of this can be typed on the calculator very easily. With sec 40, you got to be a little bit, you can't just type it on the calculator because our calculators only have sin, cos, and tan. But what we must remember is 1 over cos. Cosec, let's write cosec is 1 over sin, and then cot is 1 over tan. So you can rewrite this as 1 over cos 40 plus everything else stays the same because it's all just sin, cos, and tan. Okay, that didn't have a bracket, my bad. Sin squared 28 multiplied by 1 over 4 cos 62. Now you're just going to plug it on the calculator. With this part, the way that you type that on the calculator is you open up a bracket, then you say sin. Now that'll open up its own bracket, and then you close that, and then you put a 2 on the outside, like that. Now, if you had to go type all of this on the calculator just like that, you should get you should end up with 0. It's like 0.799, but if you round that, it'll be 0.80. This question wants us to solve for theta. So whenever we have to solve for theta, you need to get sin, cos, or tan, and this part with the bracket. That part you need to get completely by itself. So this part needs to be taken to the other side. So you would multiply it on the other side. Because if you multiply this side by 2, and then what you do to the one side, you do to the other side. And so this 2 and this 2 would cancel. And so we now have cos 2 theta minus 10 equals to 0.091 multiplied by 2. And so we end up with cos of 2 theta minus 10 equals to 0.182. Okay, now when you're in this situation, don't worry about what you have over here. Just ignore that. Okay, so we can just pretend that we've got cos of some angle, and that cos of that angle is equal to 0.182. Now to work out what this angle is, your teacher might call it the reference angle. Then you're going to say cos. Well, first on your calculator, you're going to say shift, then you're going to press the cos button, and that's going to open up a little thing like that, and then you're just going to say 0.182. If you get that on the calculator. Okay, I'm just going to write down the first 4 decimals because this is not the final answer. So that'll be 5137. So that means that this part, which is the angle, is that. So we can now say that this part, which is the angle, is actually 79.5137. And now you're just going to get theta by itself by taking the 10 to the other side. So that's going to be 89.5137. And then if you had to get theta alone, by dividing both sides by 2. And then here they said to 1 decimal place, that'll be 44.8 degrees. This question says, without using a calculator, determine the value of this. Now look at these angles. 60, 45, 45. Those are special angles. And then this part here, you'll see what will happen. That'll be a really easy part. Okay, so we need to go get our special triangles. So we know that we have 2 of them. They're both 90 degrees. Now here I'm just going to put a 30 degree. Here will be a 60 degree. Okay, now opposite the 30 is always going to be a 1. And then the hypotenuse is always going to be a 2. And then this one's always a square root 3. Then for this triangle, it's a 45, 45, and so this is a 1, this is a 1, and then this is a square root 2. So make sure you understand those, okay? You just got to memorize them. Alright, so if you look at sin 60 over here, so I rather want you to write it like this. So you're going to say sin 60, that's how it will look on your, well actually no, we don't have to because we're not going to use a calculator. So you're just going to say sin 60 and then you square it. That is what sin 60 squared means. You just do it like that. This will just be sin 45. Sec 45. Now we don't have sec on these triangles, but I mean we usually just use sin, cos, and tan, but you must remember that sec is 1 over cos. Okay, so sec is 1 over cos. So I'm going to change this to 1 over, well, no, we can actually just leave it as sec 45. That's fine. And then a quarter tan of 10, and then just remember cot is 1 over tan. Okay, so we will change that one just now. Right, so let's go work everything out. So if you work out sin 60, so let's go to sin 60 now. So sin, if we use SOHCAHTOA, which I'll write over here. So sin is opposite over hypotenuse. So if we go to sin 60, then we're going to go opposite over hypotenuse. That's square root 3 over 2, like that. Then you're going to say minus. Now sin 45, so you go to the 45 degree triangle, any 45 that you like, it does not matter. And if you look for sin, it's going to be opposite over hypotenuse. So we're just going to say 1 over square root 2. Now sec 45 is 1 over cos 45. So if you work out, so we could just say here 1 over cos 45. Or we don't even have to do that. We can actually just see, let's see what cos 45 is. Cos 45 is, we know that cos is adjacent over hypotenuse. So we could say adjacent over hypotenuse. So then sec 45 would be the opposite. So it would be square root 2 over 1. So square root 2 over 1, like that. Okay. Now, there's no way to handle the tens, but I'll show you something pretty cool. So tan 10, just leave it as it is. Now, we know that cot is 1 over tan, so we can just write this as 1 over tan 10. Now, over here, we have a square root 2 at the bottom and a square root 2 at the top, so they can cancel. And then here's the really cool part. We have a tan 10 at the top and a tan 10 at the bottom, so they just cancel out. And so if you type that on your calculator, that's just going to give you 3 over 4, okay? And then here we're just going to be left with negative 1, and then here we're just left with plus a quarter. Okay, so if you had to work that out, that would be 6 over 4, because remember this is the same as 2 over 1. And then you're going to say minus 1 plus a quarter. Now go get a common denominator. That common denominator would be 4. So you're just going to multiply this bottom part by 4, and what you do to the bottom, you do to the top. Let me write this a little bit better. So it's minus 1 over 1. Okay, so we're going to multiply bottom by 4 and the top by 4, because what you do to the bottom, you do to the top. And so this is going to give us 6 over 4 minus 4 over 4 plus 1 over 4. So that's going to give us 6 minus 4 is 2. 2 plus 1 is 3. On the answer sheet, which I've put over here, it says sketch the graph of sin x plus 2 and 2 cos x on the same system of axes from 0 up to 360. And then, okay, use the sketch graphs to answer the following. Okay, so let's go sketch. Now, when you sketch, you just use your calculator. All right, so here we have it. So you're going to put your calculator into the, what do we call it? The table mode. So whatever that is for yours, you just say mode and then choose the number that gives you table mode. Now you're just going to go type in the 2 equations. So the first one is sin. Now to get x, you press alpha and then you press this right bracket. Okay, and that's got an x, and then you say plus 2. Just like we see up at the top of the screen. Then we say next. Now g of x is going to be 2 cos x, like that. Press equals. Okay, now your starting position, that's very interesting. Your starting position is whatever this number is. Your ending position is whatever this number is. So for the start, we will say 0. For the ending position, we'll say 360. And then your step. Well, for a sin and cos graph in grade 10, we will use a step of 90. Okay? And so you press equals, and there's all the values. You see, so they give you all of the x values, 0, 90, 180, 270, 360. You see how they're going up by 90? That's your step. And then they give you the y values. So that's the y value for the graph of f, and that's the y value for the graph of g. So let's go, I'm going to quickly go write all these values down. Alright, so let's go put our x values. So our x values are 90, so this is 90, 180, 270, and 360. Okay, so I'm going to start with the graph of f. So when x is 0, its y value is 2. So when x is 0, its y value is 2. So let's say this is 1, this is 2, this is 3, minus 1, minus 2, minus 3. Okay, then when x is 90, its y value is 3. So when x is 90, its y value is 3. When x is 180, its y value is 2. When x is 270, the y value is 1. And then when x is 360, the y value is 2. There we go. Draw the curve. Okay, so that would be the graph of f. Now we can do graph g. So when the x value, remember this is your x, when the x value is 0, then the y value of g is 2. So that would also start over there. And then when the x value is 90, the y value is 0. So that would be there. And then when the x value is 180, the y value is minus 2. And then 270 and 0. And then 360 and 2. Okay, let's draw it. So that is sort of, it's not the best looking drawing, but that's what graph G would look like. Okay, graph G. Now, this question says, write down the range of G. So the range, and I just wanted to add the marker location over there. Okay, so the range is the y values. So you could either write it like this. You could say y is an element. Now the graph of G goes from minus 2. So you start with the lowest value first. And then it goes up to positive 2, like that. Okay, if you prefer set builder notation, you could say that y is bigger than or equal to minus 2 and smaller than or equal to positive 2. This one says, for which value of x will f decrease? Now, what does decrease mean? Well, it means going, when you're starting from left and you move towards the right-hand side, when is the graph going downhill? So if we start here, okay, here we see this red graph is going uphill over here, So imagine you're driving a car. So here's your car. And you're going uphill, uphill. Suddenly you start going downhill up to that point. So from here to here, you were going downhill. Okay? So that is what we mean when we say decrease. So you could say, you could either use interval notations. You could say when x goes from 90, but now we're not going to include the 90. I'll explain why now. Just give me a moment. I just want to write this down. And then all the way up to 270. We're not going to include it. If you wanted to use set border notation, you would say x is bigger than 90, but smaller than 270. So why don't we include the 90 and the 270? Well, at the 90, what is the graph doing? Is it going up, down, or is it not doing any of those? Well, at the 90 itself, it's busy turning, so it's completely flat. It's not increasing and it's not decreasing. So you see, that is why we don't include the 90, because they said, where is the graph decreasing? And it's not decreasing at 90, but it starts there. So we're just saying that that's the starting position, and then the same at 270. Okay, so we'll use a round bracket over there. So with this question, I will split the questions up onto different pages, because here we've got an 8-mark question, so we're going to need a bit of space for that one. So yeah, let's begin. So I'll start with the first 3 questions over here, and then remember that we have got that big 8-marker coming up. Okay, so they give us the following points, and they say find the midpoint of RS. Okay, so we know that to find the midpoint, we use the midpoint formula, which is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So they said between R and S. So I'm just going to use R as my point number 1 and S as my point number 2. And so if we then work that out, it says that we must take the x value of point number 1, which is a 2, and then the x value of point number S, which is also a 2, and we're going to divide that by 2. And if you work that out, you would get 2. Now for the y values, you would say 5 plus minus 3 divided by 2, and if you work that out, that is going to give you 1. So the midpoint will be 2 and 1. Now this question says find the coordinates of point T so that RUST is a parallelogram. Okay, so let's go draw this out quickly so you can just get a better idea. So it doesn't have to be a super accurate drawing, but let's just see 2 and 5. So 2 and 5, so that would be R, and that's 2 and 5. And then U is minus 2 and 1. So minus 2 and 1. So that would be like there, for example. So that's U. So that's minus 2 and 1. And then S is 2 and negative 3. 2 and negative 3. That would be around there. So 2 and negative 3. And that's S. Now the order is very important. They said RUST. So it's R to U, then to S, and so T would have to be somewhere over here, okay, for it to be a parallelogram. Now, it's very easy to do these questions. All that you do, and I forgot to show you guys the mark allocation over here. So this is 2, this one was 3. I know this because of the previous slide. Okay, I just forgot to copy them over. So 2, 3, and 2. And then we've got the 8 marker coming up. Okay, so it's really easy. What you do is you just look at, there's different ways you can do this. So let's say from U to R, you need to see what happens to the X values, okay, and what happens to the Y values. So let's just write this a little bit better. So here the X values go from minus 2 to positive 2. So how much do they go up by? Well, the X values went up by 4. Okay, so we're going to do the same for S going to T, because it does the same. Whatever happens from U to R is the same as what happens from S to T. So we're going to add 4 to this one as well, so that's going to become a 6. Now let's see what happens to the Y values. It goes from 1 to 5. So what did they do to the Y values? They added 4. So we're going to do the same to this. If you add 4, that'll become a 1. And so that is the coordinates of T. There is another way that you could have done this one, and that is the following. We have just found the midpoint of RS. Okay, we've just found the midpoint in the previous question. We found that as 2 and 1, remember? When we did this question here. So that midpoint is also going to be the midpoint for this line. So we now have the midpoint of UT. So let's say we didn't know what this was. We didn't know the coordinates, okay? So then you could say that these coordinates will just be x and y. So then you could use the midpoint formula for UT, so the midpoint of UT, and so the midpoint formula would be x1 plus x2 over 2, y1 plus y2 over 2, and so the midpoint would be negative 2 plus x over 2, and then the y would be 1 plus y over 2. But we know what the midpoint answer is. For the x values, it should be equal to 2. So we could say minus 2 plus x divided by 2 is equal to 2. And then for the y values, that's equal to 1. And so if you had to then solve, you could take this 2 and multiply it to the right. So you'd end up with minus 2 plus x equals to 4. And then you take you take this number to the other side. So you end up with x equals to 4 plus 2, which is 6. Then over here, you multiply the 2 over. So you end up with that. And then you take the 1 over to the other side, where it ends up becoming 2 minus 1, which is 1. And so we also end up with 6 and 1, just like we did when I showed you the other method. Okay, now this last question for 2 marks says calculate the length of RU. Okay, that's easy. We just use a formula for that one. So the distance formula, or length formula, whatever you want to call it, goes like that. So I'm going to use this as my point number 1 and this is my point number 2, and then I'm just going to follow the formula. So the formula says I must take the x value of point number 2, which is a 2, minus the x value of point number 1, which was a negative 2, and then the y value of point number 2, which is a 5, and then the y value of point number 1, which is a 1, and then I just go type that all on the calculator like that. And then in this one, they've asked us to leave the answer in surd form. That just means with a square root. So that would be 4 square root 2. Don't go write it in decimal form. So here we have the 8-mark question. It says, given that RU, which is this line over here, is parallel to SP. Okay, so that means P is going to be somewhere along this line, or it could even be further and further, because this line is parallel to this line. So that's what they're saying. They tell us that the length of SP is double the length of RU. Okay, so P could be anywhere on this line, like we said, but the length of SP is double this length. Okay, so P would then have to be like here, or it could even be all the way back here, so that this length, SP, is double this length, but it could also go this way. So SP is double that length. So P has 2 different places that it could be. It could be here, and it could be here. Now, I don't know why it's 8 marks. There is a really easy way to get the answers, but I'm not going to go through that because, yeah, it's for 8 marks, and we obviously have to show our working out. Oh, and they say, find the coordinate of P such that RUSP is a trapezium. Or with the other one, it could be RUSP. So those are the 2 different trapeziums you could make. Okay, so we know that P is either going to be here or P is either going to be down here. Now, we need to just come up with a whole bunch of information, because at the moment, let's just forget about the fact that there's 2. The mathematics will work out and it'll give us 2 answers, which is pretty beautiful. So what we can do is we can first say that these 2 lines are parallel. We know that they're parallel. Parallel lines have the same gradient. So let's go work out the gradient of this line so long, and then we can make that the gradient of that line. So to work out the gradient, we use the gradient of UR. We're going to say y2 minus y1 over x2 minus x1. That's the gradient formula. I'm going to use this as 0.2 and I'll use this as 0.1. And so that's going to be 5 take away 1 over 2 minus 2. And that will give us 4 over 4, which is 1. So the gradient of UR is 1. And so therefore the gradient of SP is also 1. Okay? The gradient of SP is also going to be 1. Remember that. That's important. Okay, the next thing is they tell us that the distance of SP is double the distance of UR. Now, we worked out UR's distance in the previous part, remember over here, and we got, it was 4 square root 2. You remember that? So now we can say that the distance of SP is double that. So 2 multiplied by 4 square root 2 is 8 square root 2. Now we have two very important pieces of information for SP, and that's perfect, because now we can go work out the gradient. We can go look at the gradient of SP, but what we can do is we can say we already have the answer. We know that the gradient is 1. Then I'll use this as 0.2 and I'll use this as 0.1, and so you're just going to fill in y minus 3 and then x minus 2. Now a minus and a minus is a plus. Okay, and so I'm going to take this x minus 2 over to the other side where you multiply it with the 1. So it becomes x minus 2 equals to y plus 3. So there's an equation. Let's just leave that equation like that for now. Let's call that equation number 1. Then I'm going to come work over here where we can say that the distance of SP, and then we use the distance formula, okay? And we know the answer. We know that the answer is 8 square root 2. Now, I'm going to keep this as point number 1, and I'll keep this as point number 2. And so that'll be x minus 2 plus y minus 3. Now remember, minus just becomes a plus. Okay, and so there we have this formula now. So you see what happens is we have two unknowns, x and y, but we have two equations. So mathematically, this will be able to be solved. Okay, so if we take this equation and let's just rewrite it for ourselves over here. Now, what you want to do to get rid of the square roots, you have to square both sides. So you square and then you square. What that does is this square gets rid of the square root. So on the right hand side, we're just going to have x minus 2 squared and y plus 3 squared. Okay, on the left hand side, you could just type that on your calculator, and that's going to become 128. Okay, now what we can do is, there's different ways that you can do this. So you can take this equation now and get the y value by itself, or you could have gotten the x value by itself. It doesn't matter, but we can say that y is equal to x minus 2 minus 3, and so y would be equal to x minus 5. Okay, so y would be x minus 5, and we could call that equation number 3, and this is equation number 2. Now we can just use substitution, so we can just go and substitute number 3 into number 2. So you see there's the y equals to x minus 5, so we can replace that y with x minus 5. So we'll now end up with 128 equals to x minus 2 squared plus the y value is x minus 5 plus 3 squared. And now we're just going to go solve. So here we would end up with, this just becomes x minus 2. Okay, now we're just going to go solve. So I'm going to multiply out the two brackets. So you're going to end up with x minus 2 and then x minus 2. And then here we also have x minus 2 and then x minus 2. So we're going to end up with 128 equals to x squared minus 4x plus 4. If you did the x squared minus 2x, that would give you minus 4x. And then plus 4. And then x squared minus 2x plus 4 again. So that'll just be minus 4x. And then plus 4. Okay, so now if we simplify further, we're going to have x squared plus x squared is 2x squared. And then minus 4x is minus 8x. And then plus 4 gives us plus 8. Now I'm going to take the 128 over to the right hand side. You could take everything to the left, but I just don't like having a negative for this one. So I would rather take everything over to the right hand side. And so we end up with that over there. And so then what we can do is we can divide everything by 2. And so we end up with x squared take away 4x take away 60. And now we need to factorize. So the number 60 can be written as 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. Now, you need to find the correct combination that would give you negative 4. And that would be this one over here, 6 and 10. Why? Because 6 minus 10 would give you negative 4. So we're going to open up two brackets now, and we're going to say positive 6 and negative 10. And then you're just going to say x and x. And so then you can say x plus 6 is equal to 0, or x minus 10 is equal to 0. And so x is negative 6, or x is equal to 10. Now that we have the x values, we can go work out the y values by just plugging it back into this equation. So if x is negative 6, then y would be negative, or you can, I don't want to confuse anyone, so then I could say y is equal to negative 6 minus 5, so y is equal to negative 11. So if x is negative 6, y is negative 11, so that's one of the coordinates for p. And then here we can try another one. If x is 10, then y would be, if we use this, 10 minus 5, and so y would be 5. So x would then be 10 and y would then be 5. So remember I showed you on the original diagram that there could be two possible values where p could be, and we said that p could be somewhere up here, or p could be somewhere down here. And so here we have the two values. So negative 6, negative 11, that's our one answer. And then 10 and 5, that is our second answer. If the opposite angles of a quadrilateral are equal, then the quadrilateral is... Okay, now this is going to be a parallelogram. Now, some of you might have said like rectangle, for example. Now, I do agree with you that in a rectangle, if the opposite angles of a rectangle are equal, okay? But they specifically have to be 90 degrees for them to be considered to be a rectangle. You might have said a rhombus, but with a rhombus, the opposite angles are equal. I do agree with you, but the four sides also have to be the same. You might have said a square. Now, the opposite angles of a square are equal, but they have to be 90, and the opposite sides have to be equal. So the only shape where that you can say if the opposite angles are equal, then it's a parallelogram. Because then if these are equal and these are equal, then automatically that shape is a parallelogram. We know that there are four ways to prove that something is a parallelogram. Either you can prove that the opposite sides are equal, and you only have to prove one of these to prove that something is a parallelogram. And this is both pairs of sides. Both pairs of opposite sides are equal. You could use both pairs opposite sides parallel. You could say opposite angles are equal. Opposite angles are equal. Or you could say one pair of sides equal and parallel. Those are the four ways to prove that something is a parallelogram, but you don't have to prove all four of them. You only have to prove one. And so here we go. If the opposite angles of a certain shape are equal, then it's a parallelogram. So as we said, this answer is parallelogram. In the diagram below, ABCD is a quadrilateral. E is a point on AD such that AE is the same as AB. Okay, so those two lengths are the same. And then EC is the same as CD. So those are the same. Now, let's see. D is 2x. B1 is x. Okay. And then AD is parallel to BC. So these two lines are parallel. All right. So the first question for 4 marks says, what is the value of x? Now, you cannot say that this angle and this angle is the same because this is not a parallelogram. They said it's a quadrilateral. So, what we could do is, okay, you see here we've got an isosceles triangle, right? What is an isosceles triangle? An isosceles triangle is one where two sides are the same. Two sides are the same, okay? So, if two sides are the same, then two angles are the same. Now, which two angles? Well, it would be the two angles that are opposite those sides. So it'll be that one, and it would be that one. Okay, so that's how we will start. We will say that angle E1 is going to be the same as angle B1, and they're both then going to be equal to x. And the reason is that we have equal. Now, there's different ways that people write this, but one of them is that we have equal, or you could even say equal angles opposite equal sides. So we have equal angles because they are opposite equal sides. So this is now x. Okay? Now, we could use parallel lines over here, and we could say that this, we could say that this b2 is equal to x. We could say b2 is equal to x. And the reason for that is that we have alternating angles, and that is because AD is parallel to BC. Okay? And so that's x. Now we're going to do the exact same process on this triangle because this triangle is also isosceles. So we know then that this angle will be the same as this angle. So we could say angle E3 is the same as angle D, and that is because of, once again, and they're both equal to 2x, and that's once again because of equal angles opposite equal sides. So this is now 2x. We can then use alternating angles, and that would show us that this is now 2x. But let's go write it down. So C2 is 2x. Why? Alt angles. Why? Because AD is parallel to BC. Now, if you look inside this triangle, what should all of those angles add up to? Well, they should add up to 180. So we could say that angle E2 plus angle B2 plus angle C2 must add up to 180, and that is because of the sum of angles in a triangle. And so E2 is 90, B2 is x, C2 is 2x, like that. Now you can go and solve for x. Okay, so let's just write that down. 90, now 2x plus 2x is 3x. Okay, and then if you had to get x by itself, you would say 180 minus 90, and so 3x would be equal to 90, and so x would be equal to 30. Okay, now, so we know that x is now 30, so we can go put that in as 30. This would be 60, this would be 60, and this would be 30. And this would be 60, and this would be 30. The next one says that prove that this shape is a parallelogram. So there are 4 ways that you can prove something is a parallelogram. Let me tell you what those 4 ways are. You either need to prove that both pairs of the opposite sides are equal. So like you have to prove that these 2 sides are the same, and then you have to prove that these 2 sides are the same. Okay, that's what that means. So you have to do it for both pairs. You could also do both pairs of opposite sides are parallel. So you don't have to do both. You only have to do one of these. And then the other option is you could prove that both pairs of opposite angles are equal. Both pairs of opposite angles are equal. Okay? Or you could prove that one pair of opposite sides equal and parallel. So you could prove that one pair of opposite sides, so instead of choosing both pairs, you can choose one pair, but then you have to say equal and you have to show that they're parallel. Okay, now you only have to use one of these. So it depends, each question depends when making the decision of which one to use. So I think the angle one is going to work best for this. Okay, the angle. So we need to prove that this angle and this angle is the same, and then we need to prove that this angle and this angle is the same. So we can already see that this angle is 60 and this angle is 60. Okay, so we can say that angle ABC, which is ABC, so it's this whole angle, is already the same as angle D, because they are both equal to 60 degrees. Okay, so we've got those two. Fantastic. Now we just need to show that these 2 angles are the same. So to do that, we're first going to have to go work out angle A. So we can just work in this triangle over here, and we could say that angle A plus angle E1 plus angle B1 must add up to 180. And that is just because of sum of angles in a triangle. And so that's going to be angle A plus angle E1 plus 30 equals to 180. And so angle A is going to be 120 degrees. Okay, now we're going to go work out this angle, but to do that we need C1 first, and to do that we can just work in this triangle. So we could say that angle E3 plus angle D plus angle C1 must add up to 180. Once again, sum angles triangle. So then we could say 60 plus 60 plus angle C1. And if you had to work out angle C1, you would end up with 180 minus 60 minus 60. And angle C1 would be 60. So if you then had to look at this whole angle, C1, or let's just call it DCB. DCB. So angle DCB would then be 120 degrees. And so look at this now. We've got that this would be 120 and this is 120. So we've got these two equal and these two are equal. So this thing is a parallelogram. So we can say therefore ABCD is a parallelogram. Now your teacher might write it like that or PARM, I'm not sure. And the reason that you could use is that the opposite angles of the quadrilateral are equal. And the reason that we can give is both pairs of opposite angles equal. Alright, so here we have a 5-mark question. It says, in the quadrilateral given, diagonals AC and BD bisect at O. If AC is equal to 4xy, okay, so AC is equal to 4xy, and BC is equal to x squared plus y squared, and BD is equal to that. Jeez, what are they on about? 2x squared minus 2y squared, and that's 4xy. Okay, so I decided to do it in different colors like that, so we know exactly what we're talking about here. Okay, then it says that prove for 5 marks that this is a rhombus. Okay, so what is a rhombus? A rhombus is, it's a shape that looks like this, where all 4 sides are the same length, okay? All 4 sides are the same length, and the diagonals bisect at 90 degrees. Alright, now here is something quite interesting. They said that the diagonals here bisect. Bisect. Bisect means cuts in half. So that means that this line, this red line, has been cut in half. So what we can say is that this length here would be 2xy, and then this length would be 2xy. Okay? And then this length, instead of having 2x squared minus 2y squared, we can divide that by 2. So 2x squared minus 2y squared divided by 2. So then you divide both of these by 2. So it ends up becoming x squared minus y squared. So that means that this is going to be x squared minus y squared, and this will be x squared minus y squared. Okay. Now, because we know for a rhombus that the diagonals hit at 90 degrees, I want to take this triangle, for example, and I want to try see if this is a right angle triangle. I want to see if that is a 90. So I'm going to pretend, or I'm going to try see if Pythagoras works, okay? So I know that with Pythagoras, the way that Pythagoras works is if you have a triangle, then if you want to work out the longest side, which is the one that is opposite the 90, then you just take the other 2 sides squared and you add them together like that, okay? So I'm going to do that for this triangle and see if it does work out. So the longest side would be this one, okay? That's the longest side. It would have been that one. So I'm going to take that one. I'm going to take the other 2, x squared minus y squared, and I'm going to square that. And then I'm going to take the other one, and I'm going to square that. And let's go work this all out and see what we get. So if you have this, it's x squared minus y squared, and then x squared minus y squared, and then plus 2xy multiplied by 2xy. That one we don't really have to put into double brackets because it's only one term over here. So we can actually just write it as 4x squared y squared. Okay, so let's go multiply this out. So x4 minus x squared y squared minus x squared y squared plus y to the power of 4 plus 4x squared y squared. Okay, so these parts can now be put together with that part over there. So that's going to give you x4, and then this is minus 1, which is minus 2, plus 4 gives us positive 2. So 2x squared y squared, and then plus y4. Okay, so that's what you get if you add the square of that and the square of that. To see if Pythagoras works now, I now need to go get this one and see what that would be squared. Okay, so that's going to be x squared plus y squared, and then another x squared plus y squared. So that would give you x4 plus x squared y squared plus another x squared y squared plus y4. Then if you put these two together, that would give you 2x squared y squared. So 2x squared y squared. And so what we can see is that Pythagoras is actually working perfectly. Pythagoras says that if you take these two squares, so those two, and you square them and you add them, then it should give you the same as this one squared. If that works, then that is Pythagoras, and Pythagoras only works for a 90 degree. So what we can then say is that x squared minus y squared plus 2xy squared was the same as x squared plus y squared. So we could say, therefore, angle BOC is equal to 90 degrees. Now, another thing is that, okay, so we can say that this is 90 degrees. So it almost looks like it's a rhombus, but that doesn't mean it's a rhombus just yet. Because if we look at a rhombus once more, a rhombus also has, so we said that a rhombus has the diagonals that hit at 90 degrees, but a rhombus also has to be a parallelogram. Okay, so we need to make sure that this is a parallelogram first. Now, there are 5 ways to prove that something is a parallelogram. Sometimes I say there's 4, but then I forget that there's this 5th one. 3, 4, okay, let's write this somewhere else. Okay, so there are 5 different ways to show that something is a parallelogram. Number 1, both pairs of you would have to show that both pairs of opposite sides are equal. You could also show that both pairs of opposite sides are parallel. You could also show that the diagonals, I'm just going to say the diagonals, bisect each other. Okay. The other one is that the opposites, you could say both pairs of opposite sides are equal. And then the last one is you could say that one pair of opposite sides equal and parallel. So in this introduction part of here, they said that the diagonals bisect. So because the diagonals bisect, we know that this is a parallelogram. So a rhombus is a parallelogram that has a 90 degree, where the angles bisect at 90 degrees. So this is a rhombus. And so, yeah, they already told us that the diagonals bisect. So we can say, therefore, ABCD is a rhombus. And that is because the diagonals of this quadrilateral bisect. That's important. They bisect at 90 degrees.